Hello guys, today we're going to start chapter 5. We're going to do lesson 5.1, graphing quadratic functions. I'm going to just keep going and not leave time for writing. So if you need to stop and write something down, please just pause the video. All right, so a quadratic function is a parabola. Okay, that's what they're called. This is the standard form for a quadratic function. I'll write over here, standard form. Okay, so it is ax squared plus bx plus c. The important part to note is that a cannot be equal to 0. This a has to be a number that is not 0, or else it is not quadratic. Okay? This squared term is called your quadratic term. The x term is your linear term, and your c term is your constant. So the first thing we're going to do is we are going to graph one of these, all right, by making a table. So we aren't quite sure where this is going to go, so I'm just going to make a table of values. Okay, so I'm going to pick some x's. So I'm just going to go with 0, 1, 2, 3, 4. When you do this, you'll kind of have to look and see whether the x's are showing you a parabola, if your x, if it's switched locations, what's going on. So what you're going to do is you are going to take your 0 and you are going to plug it in everywhere that x equals 0. So I'm going to have 2, 0 squared minus 8 times 0 plus 9. And I'm going to throw that in my calculator and find out that that one equals 9 right here. Okay, so I'm going to plug all of those in. Now I'm going to plug in a 1. When I do that, I get a 3. Plug in a 2, and get a 1. Plug in a 3, and get a 3. And a 4, and get a 9. Okay, do you see how right here at this point, we're going down, and then we go back up. So this point right here is going to be like the bottom of our parabola. You need to see your numbers move like this. You need to see them go down and back up, or you need to see them go up and back down, and then you'll know you have enough information to put your graph in. Okay, so these points right here, this is going over to 0 and up 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 1, 3, 2, 3, 2, 1, 3, 3, and 4. We'll go back up here to 8, 9. Okay, and then you make your parabola curve around. So when I say that it is a parabola, this is what a parabola looks like. It looks like a U. Okay, and that is a quadratic function or a parabola. Okay, if it's not working and you're not finding a bottom, okay, try some numbers maybe on the other side. Take a look at your graph. If your numbers are starting to get really big, plug some numbers in on the other side to see what those are going to do. All right, so this is the graph of a quadratic equation. Ax squared plus bx plus c, that was our standard form we talked about. Okay. So the first thing I'm going to show you here is we've talked about parent functions, and this is just our regular x squared function. So if we were to plug the points in, our x squared function looks like that. Our bottom of our parabola starts at 0, 0. Okay, our next point goes 1, 1, and so on. That's really not what matters as much as this stuff over here. So here I have, that'll be good. This information is kind of what you need. This is my parabola here. If you notice from the one above, that when we graphed it, both sides kind of look like a copy of each other. It's because they are, okay? All right, so let me give you some information here. Let's start. Here's my parabola in purple, okay? This right here, this y-intercept, that happens when we have a 0 where the x's are, and our y-intercept actually happens at C. So whatever letter C is, that is going to be your y-intercept. Okay. This thing right here, this pink dotted line, that's called your axis of symmetry. Your axis of symmetry, the line for your axis of symmetry happens at negative b over 2a's. That's where your middle line goes. That axis of symmetry line goes through this bottom point, which is called your vertex. We can find the x coordinate of our vertex by doing our negative b over 2a. Okay. And that'll find where the x of our vertex is, and then we will be able to find our y. All right, so these are the two important pieces of information here, that the C is the y-intercept, and then we can use negative b over 2a to find this middle axis of symmetry and help us find the vertex. Okay. All right, so we have a problem here that asks us to find the y-intercept, the axis of symmetry, and the x of the vertex, and use that information to graph. Our y-intercept, it says up here, that happens at our C. Okay. This equation here is not in the proper order, so let's move it around. I'm going to make it x squared plus 8x plus 9, so it is in the right order. And now we can see our y-intercept is right here at this 9. So the y-intercept is going to be 9. Axis of symmetry is going to be negative b over 2a. Right. If we need a actual equation for it, it's the x equals. So let's plug those in. So my b is an 8. My a, remember when there's not a number in front of it, is a 1. So I'll have negative 8 over 2, or x equals negative 4. Okay. That's where the vertical line goes that cuts my parabola in half. So that means for this right here, the x coordinate of my vertex, where my vertex goes over, is going to be at negative 4 and then something. I'm not sure what that something is going to be, okay? How I can find that something is taking my equation up here and plugging this negative 4 in. So I'm going to do negative 4 squared plus 8 times negative 4 plus 9. And then I need to solve for that vertex. Okay, so let me pull out my calculator because I don't have that. Make sure that this negative goes in parentheses when you plug it into your calculator, because that will change your answer. I got an answer of negative 7. So our point here is negative 4, negative 7. Okay. I don't quite have enough room on this piece of paper, so I'm going to add it to the bottom of this piece of paper here. Okay. I'm going to make myself a coordinate plane. Got -4, -7. I gotta leave myself plenty of room there. Okay, so I got a coordinate plane here. And I gotta graph my information. So, my y-intercept is 9. So I'm gonna have to go by 2s. 2, 4, 6, 8, 9. So my y-intercept's up here at 9. My vertex is at -4. 1, 2, 7. 2, 4, 6, 7. Okay. I also know that at that point, I'm going to have this axis of symmetry, right? Okay. Which means at this point over here at 7, okay, I can count to my line. So I got 1, 2 over, 1, 2 over here, and that will help me put extra points in. So now I can draw my parabola. It should look something like this. And all of that information I got from the equation of my line. All right. Some more information that we can find from the equation of our line is the minimum or maximum value. Okay. And that is going to be the y coordinate of our vertex. We just talked about how to find that y coordinate. Okay. You can use your x coordinate, your -b over 2a, and take that number and plug it into our function, whatever your function is, to find the y coordinate. We just did that on that last problem. All right. So, some things about finding a max or a min. Okay? The first thing is you are going to have this picture right here. When our A is positive, that first number, this down here, okay, it's on the bottom. It is the lowest point of my parabola. So that is going to be where we have a minimum. Okay. Your minimum is located at the lowest point or the bottom of the parabola. We know a minimum happens when our A is positive. Right here with our parabola going upside down, that happens when an A is negative. Right here, this is the biggest point, and that biggest point will happen at a maximum. Okay. All right, so let's see what the problem asks us. It says that we have this function. Okay, let's take a look. We have x squared, x number. It's in the right order. So let's see what's the first thing it asks. Determine whether this function has a minimum or a maximum. Okay. Well, let's see. It looks like my A right here is positive. And so I will have a min. I'm going to have a minimum. Okay. State the max or min value. So what that amount is at that spot. So what I'm going to have to do is I am going to need to find out, okay, my -b over 2a to figure out what's going on there. So my -b, well, I have a -4 over 2 times 1. A -4 becomes a 4. 2 times 1 is a 2. Or I have a 2 there. Okay. So I know that at the location 2, x equals 2, I am going to have a minimum, but I don't know what that minimum is yet. So I need to take this 2 and plug it back in here. So I'm going to have 2 squared minus 4 times 2 plus 9. Okay. And I could do this really quick or plug it into my calculator. I'll just do it really quick. So 4 minus 8, negative 4 plus 9, or 5. So this means at x equals 2, the function is going to equal 5. So our, or I could say it another way, my min is a value of 5. Okay. If I want to know where my min is at, it would be right here. This would be the where. And this, so this is the where. And this right here is the what. All right, state the domain and the range. Okay. So let's think about it. My parabola, if I have a minimum, I'm going to have this picture here. So I'm going to have a picture like this, and right here at 5, this point here is 5. That's going to be my minimum. So my domain, my x's are going to be all of them. Okay, so my x's are going to be negative infinity to positive infinity, or all reals, however you want to write that. Okay. My range, though, is going to be a little different because it starts at 5 here and everything is higher. So my range is going to go from 5 to infinity. Or I could say all of my values are greater than or equal to 5. Okay, you can pick which way you like to write it there. Okay. All right, got one more for you. It says, a tour bus serves 400 customers a day. Probably important. The charge is $5 a person. The owner of the bus estimates it would lose 10 passengers per day for each 50 fare increase. And I need to figure out how much my fare needs to be to maximize the income. Okay. So the income is going to be the number of passengers multiplied by the price per ticket. So we'll say income equals number of passengers times ticket price. I'm probably going to need to make some little like expressions for each of them. So the number of passengers, okay, that is all going to depend upon our 50, how many increases in price we do. So what we're going to say is that X is going to equal the number of 50-cent fare increases. Okay. So let's look at the number of passengers compared to the fare increases. Okay. It says that we have 400 passengers. And we would subtract 10 per fare increase. On the other end, our ticket price starts at $5 and it says it would increase 50 cents per fare increase. Right now I don't actually have a quadratic yet, but I can make one. Okay. So how I'm going to make that quadratic is I need to do my foiling. So I'm going to do 4 times 500. Sorry, 400 times 5 plus 400 times our 50 cents. And then I'll do minus 10x times 5 minus 10x times 0.5x. I'm going to have to simplify here. So 400 times 5 is 2,000. 400 times 0.5, so that's half of 400 is 200. 5 times 10 is 50. 5x squared. I have an x and x, so it makes x squared. Right here, I got to put those together. So 2,000 plus 150x minus 5x squared. Okay. I probably should flip it around to then use it. So I'm going to say negative 5x squared plus 150x plus 2,000 is going to be the quadratic I need to solve this problem. It wants to know how much the fare needs to increase in order to maximize. So I know that I have a maximum here. I need to find out what that maximum is going to be. Okay, so I'm going to use negative b over 2a, and I'm going to plug that in. So negative 150, 2 times negative 5, negative 50, or 15. So what it is saying is that in order to maximize income, I should increase my fare 15 times, which seems like a ton of money. Okay? So I should do 15 increases. All right. If I do 15 increases, that would be at 50 cents an increase to figure out how much our fare would increase. And that would be an increase of $7.50. Okay. And now it says, how much should the fare be? Well, I need to add that $7.50 onto the 5 it already charges for a total of $13.50. Okay. Be careful that you read what it's asking and you don't get caught up. Okay. There are a lot of pieces, and that's okay. Now it asks what the maximum income is. So I'm going to take the price of the fare. Okay. I could take the price of the fare and multiply that, or I'm just going to take my X right here because this is the location. I'll circle it very lightly. This is the location of where we want X to be in order to maximize our income. So our income equation up above was negative 5x squared plus 150x plus 2,000. And now I'm going to take that X equals 15 and plug that in. To see what my maximum profit would be. So use your calculator. Don't try and do this part in your head. Okay. So we're looking at the income at 15 instead of the income at X. And you'll find out that it will be $3,125. All right. So main things, quadratic has to have an x squared in it, okay? And use that negative b over 2a to find those locations. Your assignment is posted in Classroom. Have fun.